Hello, welcome. Today I'm going to solve Leetcode problem 128, longest consecutive sequence. So I'm going to use unified to solve the problem. Basically, the idea is that I'm going to check the numbers. For example, inside the nums, I'm going to check the first number 100. If there is another number 101, I'm gonna connect this 100 to 101, but there's no, so I'm going to the next one. I'm gonna check if there's a number bigger than the current number. If it is 4, I'm going to check if there's a 5. Yeah, let me copy the nums array here, explain it. After that, I'll finish the coding. So I'm going to first check the number 100 because there's no 101. So I'm going to check the next number. So 4, I'm going to check if there's a 5. No, there's no 5. Yeah. Now I'm going to check number 200. There's no 201. So I'm going to check the next number. Yeah. And I'm going to check number 1. So for number 1, I'm going to check if there's a number 2. So if there is a number 2, I'm going to connect 1 to 2. Yeah, and then I'm going to 3. So if there is a 4, I'm going to connect 3 with 4. Then I'm going to check number 2. If there's a 3 inside the nums, I'm going to connect 2 and 3. So if 1 connected to 2, 2 connected to 3, and 3 connected to 4, now I'm sure those 4 numbers are connected, and it is 1, 2, 3, and 4, and they are consecutive element sequence. So I will return a 4. So in this way, I can use unified to solve the problem. So basically for the unified API, there's a list as the parent array, and there's also a hash table as the parent hash table. So for our problem, because the nums array is 10 to the power of 5, but inside the nums it is numbers, and those numbers can be really big. It can be 10 to the power of 9. So I have to use the hash table to implement the unified data structure. So now let me copy the hash table template. Basically, we have two templates. So one is using array for the unified. Another one is the hash table. Yeah. So for using the array, I've already solved many questions. So this question is actually for the hash table. It is much simpler, and it is similar to the array. Yeah. Now let me copy the hash table structure for the unified. So basically, this is for solving the separate values. For example, inside the node, they are not like 1 to 100. They are just separate, but the length of the nums is 10 to the power of 5. So it means in ON, we can solve the problem. Otherwise, if it is 10 to the power of 9, we cannot solve it like, if we are using a list. So this is why we're going to use the separate node. We just use a parent should be n, k, and value should equal to n as default. So for n in nums, and the find would also be similar. If this n not equal to its parent of n, so we just need to call this function self.parent n should equal to self.find, and we need to call this recursive function. And finally, we just need to return the value of the hash table self.parent with this n. Yeah, and the union is the same, just prepare to parent, and then self.parent1 equal to p2. So this just means p1's parent is p2. So from here, I didn't do any path compression, but I'm sure I can pass for the Leetcode in ON. Now let's just prepare for this problem. So now I'm going to prepare the unified should be equal to UF, and inside here, this data structure inside, it will be an array. So inside, I'm gonna put a nums inside. It will not be a number. It's just an array. And I also need to prepare the nums to be set, because I need to check the values if a number is inside nums. So in set, I can do it in O1 operation. Otherwise, I cannot pass for the Leetcode. Yeah, because it will be O n square. if I were to make ON, so I need to prepare the nums to be a set. Yeah, because if there are duplicate numbers, it doesn't matter. We just need to check the longest consecutive elements, like 1, 2, 3, and 4. Now I'm going to check the nums. So for n in nums, I'm going to check if n plus 1 in this set of nums and they are not connected, I'm going to connect them. Yeah. And how should I check if they are not connected? I can just use uf dot find n not equal to uf dot find n plus 1. If they are not connected, I'm gonna use the union. So uf dot union with n and n plus 1. Currently, I've already connected all the components. I just need to check the maximum value. So maximum connected component. So I'm gonna prepare a dictionary should be equal to default dict, and inside it's gonna be integers. I just need to put the k values inside. Yeah. So for n in nums, I'm going to. So what is the k? The k is the uf dot find find with n plus 1. So this lines of code just means if we have 1, 2, 3, 4, if the parent is 1, yeah, that's the example. So I'm going to check, so once parent is 1, so for the k of 1 will plus 1. So when it comes to 3, 3's parent is still 1, so this 1 will plus 1, it becomes 2. So when it goes to 2, it will plus 1, because 2's parent is also 1, it's going to plus 1. When it comes to 4, 4's parent is still 1, so 1 plus 1, so the value of 1 is going to be 4, so I can return the result. So the result is the maximum of the values of the dictionary, so I'm going to return max d dot values if I have the values. So if the array is empty, I don't have d dot values. What should I do? I just need to return 0 because there's nothing inside. Yeah, if there's a d dot values, else I'm gonna return 0. Now let me run it to check if there are any typos or problems. Default dict object has no attribute value. Yeah, d dot values, there's no attribute value. It should be d dot values. I need to check the maximum of all the values. Yeah, this is just a typo because here I prepared d dot values. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed and it's pretty fast. Why? For this problem, I use the unified because unified is easy to understand and easy to think about it and easy to implement. Yeah, because basically this lines of code is just like a template. If you are practicing unified problems, normally you're gonna prepare all those templates, and it's easy to write because there are not so many lines for the parent and for the find and the union. If you understand the process, what is find and what is union. And while we are using unified, it's easy to understand if they are connected. There are also other ways. You can also use a set. If you find a 4, you're gonna check if there are higher value or lower value. It's also possible to solve, but I still that one is easy to make mistakes. Yeah, because while you are finding a number, for example 4, you have to check the upper values 5, 6, or 7. If there's no values, you're gonna stop, and then you're gonna check the lower values like 1, 3, and 2. If there's no lower values, you're gonna stop. And while you are checking, you have to pop out the numbers inside of the nums. So there's a lot of operations. But for the union find, basically you just prepare the data structure, and as you can see here, the logic is very clear. We just need to connect the component if they meet the conditions of n plus 1, and this n. If n plus 1 inside the nums, we just need to connect it. Here, like this kind of code, you can write it or you cannot, because even they are connected, we can still use a union. It doesn't matter. But yeah, just for the logic, we are checking if they are not connected. We will connect them. Yeah, this is just for saving some time, make it run a little bit faster. Thank you for watching. If you think this is helpful, please like and subscribe. I will prepare more Leetcode problems like this. See you next time.